Hi guys, in this video we will be modeling our composite material. Composite material could be woven, could be unidirectional, anything like that. So before going to that, let's take a little bit look on the environment of Workbench. On the left side we have analysis systems, component systems, custom systems, design exploration tools and ACT. We will be dealing with analysis systems and the component systems. In analysis systems we have static structural, we have elastina, we have explicit dynamics, we have transient structural, we have transient thermal. So these are different set of components. Whatever is the type of your simulation, you can choose one of the components. If we go to component systems, we have ACP pre and ACP post. In ACP pre, we just define the layers of the composites, the thickness of layers, the core, how they are laid up, what should be their directions, all things is defined in the ACP pre. And whereas in ACP post, we just look at the plies, which ply has the failure. In ACP post, we look at a different set of plies. We simply create the failure criteria in ACP post to check out which ply has been failed at different type of criteria. We have Saiwu criteria, we have Pascal and ultimate shear limits and ultimate strain limits. So all these type of criteria are defined in ACP post after the simulation. We have the engineering data where we provide the materials, something like that, and the external model type, some things. So let's drop the material designer in which we will be designing our material. So let's drop the material designer. That's it. And we will be clicking on engineering data to specify the materials those we want. Before going to engineering data, I will be showing you the fibers and the epoxy that I will be using to model my composite material. I will be using a unidirectional composite. So let's open the technical data sheets of the specific materials. So here are the specification sheets of my epoxy and the fiber. It's a unidirectional fiber. It's made by Hexel, and as far as its specifications are concerned, these are its tensile strength and ultimate elongation, densities, approximate yield, etc. We will be dealing with the tensile strength, tensile modulus in zero direction. That will be our requirement. As far as the epoxy is concerned, we will be needing the tensile modulus, that was this, and the tensile strength. Where is the tensile strength? These two we will be needing. We will be putting these values into our Ansys material designer to calculate stresses and strain, the ultimate stresses and strains of our unit cell. So let's go to Workbench. So go to engineering data, and in the engineering data, go to engineering data sources, and here there are a number of material types. We have Ansys Granta materials. So what is Ansys Granta? Ansys Granta is a new franchise found by Ansys. It basically has been purchased by Ansys. It was first an independent entity. It has thousands and thousands of materials into its library. A number of companies like Tesla, Mercedes and SpaceX collaborate with them. They test the material and send the material properties and whatever the testing parameters and values to Ansys Granta, and they add all those values into its library. We have general set of materials. So these are the general material. Let me drop it down. These are the general materials. We have additive manufacturing materials. We have geochemical materials like limestone or something like that. Then we have composite materials, which is the main topic of our video. And in the composite materials, we will be having all these type of materials. We have carbon fiber, 3 different types of fibers having different tensile moduluses. These are just the fibers. Then we have the e-glass fibers. Then we have epoxy carbon unidirectional fibers. Then we have epoxy carbon woven. Then we have epoxy e-glass unidirectional. And going down a bit, we will find different type of cores. We have honeycomb core, we have PVC foam cores, and we have sand foam cores, and we have resin epoxy. In order to add any material into my library, all I have to do is to click on this plus symbol. This material will be added in my library. Again, I will be adding carbon fiber 230 GPa, just the fiber. Obviously, I will be editing its properties. So, click on plus symbol, it will be added. Go to engineering data sources again. You can see I have these three material. This is a default material, always available. So, these are the two materials. Let's change their properties. I can also add properties if I want. If I want to add tensile ultimate strength, I will double click it from this side button. You can see the value will appear. If I want, I will right click and delete it. So what is the value of Young's modulus for the epoxy? So here is the epoxy datasheet. Let's change its name first. Copy, go to workbench and change its name, Control V. And what is its tensile modulus? Its tensile modulus is 2.81 gigapascal. So I will change its units. It's 2.81, a bit lower than that. And what is its tensile strength? It's 54 MPa. So tensile yield strength, make it MPa. It's 54. It's almost the same. Okay. Its fly type, it's isotropic. So I have defined my material. I will not be changing the Poisson's ratio. It is almost same for the epoxies. So going to carbon fiber. Let's go to carbon fiber. First, let's change its name. And let's put a unit direction in front of it. Okay, and let's convert into gigapascal. And what is its properties? So its tensile strength is 2137 MPa and its tensile modulus is 135 gigapascal. Its tensile modulus is 135 gigapascal. No need to define the tensile strength. If I need to define the tensile strength, so after defining the tensile strength, so after defining the Young's modulus or tensile modulus, which is 135, let's go back to our project like this. Now I will right click on the material designer to design the material. Now this is the main window of material designer. It's more or less like a space claim, but it's not like that. Anyway, the first thing we have to do is to select what type of material are you modeling. Obviously we are modeling a unidirectional composite. We will be selecting here UD composites. And let's see what else do we have. We have short fiber composites, we have woven composites, we have particles, we have random particles fibers or random composites. So let's click on the unidirectional composites. So this is a product tree. We will be following this tree to analyze our models and get the properties. So the first thing is the materials. Click on material, and when we will click on the material, we have to specify what is your matrix and what is your fiber. So I will be using this as my matrix and this as a fiber that I have specified initially. Click on tick. Now we'll go to geometry. What type of unit cell you want? You want a square one or a hexagonal one? I will be going for the hexagonal. What is the fiber volume fraction? I will be going for 0.45. What is the fiber diameter? It's 5 micrometer. As per my spec sheets, it is 4 micrometer. As per my spec sheet, it is 3 micrometer, and repeat count is 1. Length ratio is XZ. It's okay. I just want to create a single unit cell. Clicking on OK will create my unit cell. You can see this is my unit cell. Now I will mesh up the model. I will click on adopt towards edges, and I will again click on tick to get my mesh. Mesh has been created. You can see. Now I will go to analysis, and I will choose a constant material. This is not a variable material. So after choosing the constant material, I have to specify the names. So let's write epoxy carbon unidirectional material 1. Click on tick. It is computing its properties. Now these are the results of my material. I have Young's modulus in 3 different directions. I have shear modulus, and I have Poisson's ratio. So the properties of the material has been calculated. So let's move forward, cross it, and update it accordingly. Now it has been updated. You can see. Now let's drop ACP pre in front of this module and drop the material designer over the engineering data. Now whatever is the output of material designer, it will be shared with engineering data in block B. So right click, edit. Yes, I want upstream data. I want to read the upstream data. So this is a material which I have created just initially. We know we have created a unidirectional composites. So you can see the ply type is regular. Otherwise, it could be woven, isotropic homogeneous core, honeycomb core, or adhesive. So it's a regular ply. So that's it for this video. In the next couple of videos, I will be teaching you how to model different layers of composite fibers over a geometry, how to lay up different layers of composite splice over a surface geometry, and then we will be analyzing that model in static structural or explicit dynamic, something like that. And after that, we will be viewing our results in ACP post. Thank you.